All right, back on page 4, we're looking at number 6 of the review packet. Stronger intermolecular forces, those are going to be polar. Water cycle hexane lab, the water, you were able to float paper clips, you were able to move it around with a toothpick, and it took a lot longer to evaporate, which kind of leads into the next question of higher melting point. Well, polar is going to have a higher melting point, higher boiling point. Those bonds just don't like breaking, so it's going to take a lot more to get those to break. When I'm looking at these compounds, polar, non-polar, C6H14, that is a non-polar compound. The reason I know it's non-polar is anytime I only have C's and H's, I know that whole structure, no matter how large, is going to be a non-polar structure. The larger the structure it is, the bigger the intermolecular force you're going to have. But this question is simply just asking polar, non-polar. Next one, H2O, that is a polar compound. Okay, it's a very, very polar compound. You have your oxygen, you have two H's. This is going to form, if I kind of draw it over here, you're going to form another 2 hydrogen bonds for every water molecule. Okay, because remember this right here is the hydrogen bond, and that's the hydrogen bond between 2 molecules. You're going to get those hydrogen bonds. Very polar molecule. Sugar, polar, non-polar. Well, what I know is that sugar dissolves in water, and it's kind of going to allude to question E here, is that like dissolves like. So I know that this is going to be a polar compound, okay, because it's going to dissolve in water, which I guess we'll skip ahead, and I know that because like dissolves like. Polar dissolves polar, non-polar dissolves non-polar. Okay, oil right there, that's telling me that is a non-polar compound. The reason I know oil is non-polar is because it does not dissolve in water. Water is polar, oil is not, because they don't mix. Okay, writing formulas for each of these. Carbon tetrachloride, covalent compound, because I have a prefix, tetra a prefix for 4. So carbon, I simply write carbon as is, tetrachloride, Cl, I have 4 of them. Okay, calcium phosphate, ATE. ATE is telling me that I'm going to be looking at my polyatomic ion list for phosphate. Phosphate, ATE, PO4 negative 3. I'll go back here. So this is going to be PO4 negative 3. Calcium Ca. I have a metal and I have a non-metal. Since I have a metal and a non-metal, I have an ionic compound, calcium. I have to find calcium here. I look up, calcium is a +2, so calcium +2, so then I have to do my crisscross. I'll do it over here for you, +2, PO4 negative 3, that 3 goes there, that 2 goes there, Ca3, PO4, 2, you got to remember to put parentheses around that, and you're all set. Okay, potassium sulfide, IDE, tells me it's in a compound, and it's just an element in a compound. Potassium, pull out my periodic table again, potassium's right here, it's got a +1, and then sulfide, you're not going to find sulfide, but you're going to find sulfur. Sulfur's right here at a -2. So I've got K +1, S -2. I do the crisscross again on that, K2S. Lead 4 gives you Roman numeral 4. That's telling me Pb +4. Oxide, you're not going to find oxide, but you find oxygen at a -4. Okay, again, I'm just simply looking at the charges listed above. I got oxygen here, -2. Oh, I said that wrong. That's a 2. That's a 4. Sorry. I take those, I cross those. PB2O4. I'm not done yet. I have to reduce that down. PbO2. Okay? Yes, you have to reduce it. If you don't reduce it, it is wrong. Balance the following reactions. I'm always going to look for polyatomic ions to make the balancing easier. If you don't like doing this, that's fine. Do it however you want to do it. I see I have NO3 here. I have 3 of them. I have NO3 over here. I only have 1 of those NO3s, so I'm going to make that 3 over here. That makes my H's 3. I look over here. Well, shoot, I have 2 H's over here. 2 and 3 aren't equal. I'm going to find the least common multiple of those. And I'm just going to go ahead and try to make that 6. That makes my hydrogen 6 over here. So I'd make my hydrogen 6 here through multiplication. 3 times 2 is 6. So now I kind of reassess everything. 1Al, 6, or I should 1Al there, 1Al there, 6 hydrogens here, 6 hydrogens here, 6 N's here, 3. I have 3 over here, so that's not going to work out. So I'm going to have to up this by 6, okay, and up this by 6. Well, now I have a problem that I can reduce all these down, okay. So I'm going to reduce my everything by 3, so it's going to be 2, 2, 2, 1, okay, and then I'm all set, okay. So that's set there. Reduce those down. On my next set down here, I know 4, I have 3 of them. I know 4, I have 2 of them. Again, least common multiple. I'm going to say, okay, multiply this by 2, so now I have 6 of these. Multiply this by 3, I now have 6 of those. That 2 ups my PO4 by 2. PO4 over here, I already have 2. SO4s up that by 3, and if I do that, that changes my copper to 3, and I already have 3 copper over there, so I'm all set. Okay. Again, with balancing, there's no clean way to do it every time. You can find those polyatomic ions, but sometimes you just got to put a number on the paper and see what numbers move. All right, predicting products. First step I'm going to do is I'm going to go through find charges plus 2, minus 1, plus 1, minus 1, and all I'm doing on those, I'm finding calcium, I'm finding its charge. I'm finding bromine, I'm finding its charge. O2. These are ionic compounds, so they're going to have a cation and an anion, so you have to find those, match them up. Now, the positive here is going to want to go with the negative. The negative is going to want to go with the positive. So I'm just going to rewrite everything. CaOH2 plus KBr. Doesn't matter which set you write first or which compound you write first. What does matter is that you write the cation first. Okay. And all I'm doing is predicting products right now. I'm not even worried about balancing these. Magnesium plus 2, minus 3 for nitrogen. Again, I rewrite those Mg, and I cross the 3 and the 2, so 3, 2. Okay. Notice everything over here, you have to redo everything. You got to redo all your crosses. You can't just simply mush these things together and get MgN2. That's incorrect. Mg3N2. Okay. C3H8 and O2, that is a combustion reaction. So right away I know I'm going to get CO2 plus H2O. Okay. This looks like it'll be a single replacement reaction. It's not. It's a unique type because I have a carbon-based compound and I have oxygen. Every time it's going to produce CO2 and H2O. Plus 2, plus 3, minus 1. The 2 is going to go, the negative, positive 2 is going to go with the negative 1. I'm going to get BaCl2 plus Fe, and I'm all set. Okay. That is it for this page. This will kind of continue on in the next segment because we look back at these questions, but that's it for this page.